Understanding the concept of an orbital elevator. An orbital elevator, also known as a space elevator, is a hypothetical structure that extends from Earth's surface into space. The idea is to create a cable or tether anchored to Earth, stretching up to a satellite in geostationary orbit, allowing transportation without rockets. This concept was first popularized by Russian scientist Konstantin Tsiolkovsky in the late 19th century. How an orbital elevator would work. The elevator would operate by transporting people and cargo along a strong, tensioned cable between Earth and a satellite. The cable's lower end would be anchored on Earth, while the upper end would reach beyond geostationary orbit to maintain balance through centrifugal force. Specialized elevator climbers would ascend and descend, powered by electric or magnetic drives. The benefits of building an orbital elevator. An orbital elevator could make space travel cheaper, safer, and more accessible. By eliminating the need for rockets, it would reduce launch costs and fuel consumption significantly, potentially lowering the expense of sending materials and people to space. This infrastructure could also support frequent trips to space, fostering space tourism and exploration. The engineering challenges of an orbital elevator. One of the biggest challenges is the strength required for the cable. It would need to withstand enormous tension from Earth's gravity and the centrifugal force pulling it outward. No known material is strong enough to handle this force over such a vast distance, making material innovation crucial for a functional orbital elevator. Possible materials for the cable. Materials like carbon nanotubes and graphene have been proposed as potential solutions due to their incredible strength-to-weight ratios. However, producing these materials in sufficient length and durability is a significant hurdle. Currently, scientists can only create carbon nanotubes in small quantities, making scalability another challenge. Weather and environmental risks. An orbital elevator would face environmental risks, including high winds, lightning, and potential impacts from space debris and meteoroids. These natural hazards could damage the structure, requiring robust shielding and constant monitoring to maintain stability and safety for climbers and cargo. The cost and feasibility of construction. Building an orbital elevator would require substantial financial investment, likely involving multiple countries and corporations. The project would demand massive resources, advanced technology, and extensive safety measures. Cost estimates vary widely, but the feasibility of such a large-scale structure remains uncertain without new advances in materials and construction techniques. Benefits beyond Earth's orbit. If feasible, orbital elevators could be constructed on other celestial bodies like the Moon or Mars, where lower gravity would reduce stress on the cable. Building such structures could enable efficient transportation of materials and support future lunar or Martian colonies, making interplanetary travel and development more practical. Scientific research and ongoing developments. Scientists and engineers continue to explore the orbital elevator concept through theoretical research and small-scale prototypes. While still in the realm of science fiction, incremental advancements in materials science and robotics may one day bring this ambitious idea closer to reality, possibly within the next century. The future of space infrastructure. As humanity seeks to expand its presence in space, orbital elevators represent a fascinating, if challenging, vision for the future of space infrastructure. Whether or not an orbital elevator becomes a reality, the pursuit of such innovations will likely lead to breakthroughs that can redefine our approach to space travel and exploration.